So last week it looked at complex numbers and how we could sketch them. And how we could add them, subtract them, multiply and divide them. This is a quick summary of the basic points for a complex number. Remember, we came up with this imaginary part of the number, where j is this imaginary number, which is the square root of -1. So you need to remember that j is the square root of -1. And it's handy to remember, if that's the case, then j squared is -1. We're back in the real world again. So a complex number is made up of a real part and an imaginary part. It's possible that there is no imaginary part in an answer that I come up with, in which case I've just got a real component of this complex number. It's equally possible that if I do a calculation, I end up with no real component, just an imaginary component of this number. But together, the real and imaginary numbers to represent one vector is called a complex number. So we looked at how to represent them, polar and rectangular coordinates. So that's that last one in the drill that I forgot to look at, but that's how you'd sketch it. The imaginary part is the y-axis and the real part is the x-axis. So hopefully you sketch that correctly, the correct way around. Remember we talked in polar notation about the angle always being measured anti-clockwise from the positive real axis. We talked about adding and subtracting complex numbers. We add and subtract the real and imaginary parts separately. And we can only add and subtract in rectangular form, not polar form. So if it's in polar form, we need to convert using the calculator, and then we can do the addition or subtraction. In multiplication, we just multiply out the brackets, remembering that j squared is -1, which means we end up with a complex number at the end, which is just a real part and an imaginary part. In polar form, we just multiply the moduli, which is the magnitude in front, and add the angles or the arguments. Remembering the idea of the double negative, if that turns up. In division, do you remember this was the one we sort of finished off with? We multiply top and bottom by this thing called a complex conjugate. These are just the notes from last week. Do you remember the bottom part ends up just being these two numbers, the 3 and the 2 in this case, in the denominator being squared and added together. So we can almost do that bit separately. That's 13. And then all we need to do is just multiply out the top two brackets, which is the numerator multiplied by the complex conjugate of the denominator. Okay, just practice a few. They're not difficult once you've done a few. In polar form, it's quite straightforward. You just, instead of multiplying, you divide the moduli, and instead of adding, you subtract the arguments or the angles. Good case of the double negative here, 20 degrees minus, because we're dividing, minus 10 will give me 20 plus 10, which is 30 degrees. So just beware of that.